So we'll start with first type of design pattern, which is creational design pattern. Here we are going to cover the first design pattern, which is Singleton Design Pattern, and it is the most asked question in an interview, that what is Singleton Design Pattern, or you will be simply asked that how to create a Singleton class. Let's say why we want to create a Singleton class. So what happens is, in certain situation we just want to have one and only one object of the class. We do not want to have multiple objects of the class. So for example, there is a database connection class, there is a logger class. We just want one object of this particular class. And the Singleton design pattern ensures that only one object of the class will be created throughout the application lifecycle. Now let's see what is the problem here if we have created more than one object of the logger class. Let's take an example for the logger class. Now there is a log file, actually log 11 2025 something number log file .txt, let's say it is a file, and now we have two objects of the logger class. Both are trying to write it in the same file. So a lot of overwriting would happen, and this will ultimately lead to consistency issue. This logger file will not be accurate, and whatever the output we will be getting in logger file will be incorrect actually. So what we are trying to do here is that we want to restrict the class so that the object is created only once. We do not want multiple objects of the same class. So this will resolve the consistency issue which I have just now discussed. So how we are going to do it? There are 6 ways using which we will be creating a singleton class. One is eager, initialization, then there is lazy, then there is synchronized, double check, Pugh Solution, the last one is Enum. Let's get started with the eager initialization. So in eager initialization, what we'll do is, so this particular logger class, we want to make it a singleton class so that only one object can be created for this particular class. And we'll take this class only in throughout our example, and we'll try to make it singleton using various different techniques. How we'll make it singleton? The first thing is that we should make the constructor as private. What will happen if we'll make the constructor private? So this constructor will not be accessible outside of the class. So suppose in another class, if you want to create an object and you are saying logger equal to new logger in another class, so that will throw a compilation error because logger is not even accessible out of this class. So first we'll put this restriction of private to the constructor. Then we'll create a static logger instance basically, and we'll assign it the object right at the class loading time. So what happens when the class loads? So when the class loads, all its member will also be loaded. So once the member of the class will be loaded, what will happen is this logger instance will be given on an object of the logger class itself. And since it is also private, how to get the object of this particular logger is just creating a static method here, and we are returning the logger instance. So if one thread wants to get the instance of logger, it will just going to call the logger.get instance. So since it's a static method, it can directly call the logger.get instance method, and the instance will be returned from this method, which was already initialized at the class loading time. So this is a eager initialization. What is the problem is that once the class loads, its static member will also be loaded, and even though I'm not using this particular class, the object will be created by default. So suppose you have an application, you've written the code, you have a class for which the object can be created or might not be created. So you want to have an object when you need only. You do not want to unnecessarily create an object and keep it in your heap even though you are not using it. So what is the solution here? We'll target for lazy initialization. What will happen in lazy initialization is, so this by default we are not providing any object to logger instance. So private logger will still be there because we do not want to create object outside of this class. We want to take complete control of the logger instance object, and we want to ensure that only one object will be created for this. So now we have changed this method a little bit. what we have done is we'll check first if the logger instance is null, then we'll assign this with the new object and we'll return the logger instance. Suppose a thread wants to get the logger instance. By logger instance means the object of the logger class. What it will do, it will call the logger.getInstance method, which is a static method, so it can call directly. So once it calls the logger.getInstance method, what will happen inside this function is that the code will check whether logger instance was null or not. So if it was null, the logger instance will be given the object value and the same object value will be provided to the thread. Now let's suppose another thread wants to get the logger instance. So again it will call logger.getInstance, but this time logger instance is not null. So this whole code won't even work. Directly we will be getting the logger instance. So the new object has not been assigned to the logger instance. So once the logger instance is assigned, this if condition fails. So only one time the logger instance will be assigned the object and the logger instance will be returned. For the rest of the times, only this particular instance will be returned and no more new object will be created. So this is a good solution, but the problem is in a multi-thread system, more than one object can be created. And how we'll see how in a multi-thread system more than one object will be created. So suppose there is thread 1 and thread 2. Both have read the logger instance. Both are here at this particular point, at this line. Both are checking if logger instance is null or not. So for both of them, this particular code will be true. For both of them, this condition will satisfy. That means both will come to this place, this particular line, and both will create a new object for the logger instance. So again, two objects will be created for this particular scenario. We do not want that. And suppose there are like 100 threads which want the logger instance, and out of 100 threads, let's say 10 threads are at this level and all saw that logger instance is null. All will run this particular line and will create 10 particular logger instance. We do not want that actually. So this is the problem with this particular solution. And yeah, it defeats our purpose to create only one object. We'll use a synchronized block so that multiple threads will not be able to access it. Let's see how. So the get instance method we have just added synchronized. So what will synchronize do? It will not allow multiple threads to run this particular method. And what will happen if multiple threads are there? Only one thread will be allowed to run this particular method. So suppose T1 comes first and T1 saw that logger instance is now null. So logger instance will be assigned a new logger, a new object actually. So once the logger instance is assigned an object, it will take the object, like the function has to return the logger instance. It will take the logger instance and it will be happy about it. Now thread 2 comes because thread 2 could not have come in along with thread 1 because it's a synchronized method. So thread 2 will come and it is going to check whether logger instance is null. No, it is not null now. So it will directly take the logger instance. So in this way, no further object will be created for logger instance. So in this way, even if you have 100 threads or 1000 threads, what will happen is only one logger instance will be given to all the threads. But what is the disadvantage here? So when we talk about optimizing our application, we cannot afford the synchronized block actually. What will happen is, suppose if we have 10 threads and they all want the logger instance at the same time. Okay, so and suppose thread 1 has given this particular block to go inside and get the logger instance. What will happen is thread 1 will get the logger instance. Meanwhile, thread 2 to thread 10 will wait because they also need to get the lock over this method in order to get in and get the logger instance. So parallelly, we cannot get the logger instance here. So this is the issue here. So the instance will be given to them one by one. Thread will keep on waiting until they get the lock. So all the multiple threads will keep on waiting and will be given the logger instance one by one, which is like very inefficient. So how to resolve this particular issue? We'll use double check method. So it's a smarter way of putting the synchronized block. Okay, so what will happen is, first we'll make the logger instance as volatile. I'll cover why we are making it as volatile. Okay, but first let's focus onto this method. So we have removed the uh, synchronized keyword from this method. Now logger instance, now we are checking if logger instance is equal to null or not. So this is the part of check one. So suppose if multiple threads are there, they are coming and checking. No, they all can access it parallelly because now it's not a synchronized method. So they all came in here and at this line they check, okay, it's not null. Sorry, it's null. So they all came to this particular line and they saw that, okay, now the synchronized block starts. So only one thread will be allowed to get inside. So now what happens? The only T1 will be able to get inside here. So logger instance, and it is going to again check. So second check will be here. So logger instance, if it is equal to null, then it will be assigned a new object, and it will come out of the synchronized block. Now if thread 2 comes, because it is waiting here actually, it will come and it will see the synchronized, it will get the lock and it will go inside this synchronized block and it see if the logger instance is null or not. So it is not null actually. So that's why check 2 is required actually, because if check 2 is not in place, the thread 2 will come here and it will see and it will also create the logger object. Instead, by using check 2, thread 2 is not going to create here any more object. Now thread 3 comes after all this happens. Thread 3 comes, let's say at this point. Now it is going to check logger instance is null. No, it is not null. It is going to take away the logger instance which was created by thread 1. So here two checks are required. Basically first one is to check if the logger instance is null, and one check is once the thread goes inside the synchronized block, we are going to check if the logger instance is still null or not. So I have already explained why check 2 is required. Now let's focus on why the logger instance I have marked it as volatile. Why I have created volatile logger instance actually. So what happens is a little bit of OS knowledge is required. So what happens inside the CPU and main memory is the CPU will be divided into multiple cores. Each core will have its own cache, L1 cache, L2 cache. Suppose there is another core. So suppose it's a multi-core processor which has 3-core processor actually, and all the 3 cores will have its own L1 and L2 cache. What will happen is how it actually works is, once the L1 cache is updated, let's say, so let's see what happens at core 1. Let's say at this core what happens. So this core created a logger instance. Let's say it went inside the synchronized block and everything, it created the logger instance. What will happen is L1 cache will be updated with the logger instance, and then L2 cache will be updated. Let's say it takes T1 time for L1 cache to be updated, and let's say it takes T2 time for L2 cache to be updated. And then once the L1 and L2 is updated, then main memory will be updated. Let's say it takes T3 time for main memory to be updated. So total time it takes is T1 plus T2 plus T3. Now for core 2 and core 3, before time T, core 2 and core 3 won't even know if the logger instance is assigned any object or not, because synchronization hasn't happened in between these caches. These caches are isolated, and if the synchronize hasn't happened, both the cores won't even know about it. And let's say there is thread running on core 1, there is T2 running on core 2 and T3 running on core 3. So T2 and T3 won't even know whether the object has been assigned to logger instance or not. So in that scenario, T2 and T3 will also like to create a new object and assign it into logger instance. So again, we have created more than one instance, which is an issue which defeats our purpose actually. So that's why we have defined the logger instance variable as volatile. So what happens if you define it volatile is, if you define anything volatile, then the value will never be cached. So if I've defined logger instance as a volatile, it will not be cached. It will be directly written to the main memory. So since it will be directly written to the main memory, both cores will get to know if the logger instance has been written or not, because they are also not checking in their cache. They are checking directly into main memory because the parameter is volatile. So both cores are also not going to check within their cache because it's a volatile variable. So they are also going to check into main memory itself. So that's the reason why we have made logger instance as volatile. Now we have defined the logger instance as volatile. What is the disadvantage that we have? The disadvantage that we have here is slowness, because every read will happen from the main memory and not from the cache. So it defeats the purpose of having cache itself. So if every core has to read it from main memory, it will take a lot of time to read it from main memory, because they have to skip L1 cache, L2 cache and directly read it to main memory. So this will be a much slower process for each of the threads. So what is the solution now? Solution is Bill's Pugh solution. So in this solution, what happens is, you can see that we do not have a static logger instance within logger class itself. And we have created an inner class actually. So the outer class is logger. It does not have any static logger instance. There is an inner class which has the static logger instance, and we are assigning it eagerly. Remember the eager initialization which we did the first solution that we had. So now in this get instance method, which is still static, we are just returning the logger instance. So now you will say that, okay, what's the point? What's the whole point? You have just created a inner class. So instead of logger having its instance, you have just created a inner class where logger instance is there, and you are still doing the eager initialization. So what's the point? Is it even a lazy initialization? Let's see. So let's see how it's not a eager initialization first of all. So what happens is JVM loads class lazily only if it is reference. So this class will be loaded only if it is reference. And by class loading, I'm not saying that it has created its object. Now you see that logger builder is actually an inner class. So it is not loaded when outer class is loaded. So outer class is loaded with just this, that okay, it has a private member, which is logger builder, but it does not load the logger builder class itself. And when it will be loaded, when it is referenced, and where we are referencing it, within the class itself. So just by loading the logger class, it won't create the object of logger instance, which is inside the inner class actually. And what will happen when it is being referenced? So the class will be loaded, the inner class will be loaded. JVM guarantees that the class is loaded only once. So JVM doesn't messes it up. JVM is going to load the class. I'm not talking about object again. So it's going to load the class only once. What will happen when the class will be loaded? So when so when it is referenced, then only class will be loaded and the eager initialization will happen for the logger instance. But this eager initialization happened only when it was referenced, and not like by just loading the logger class itself. So in actuality, it is lazy initialization only and not the eager initialization for the logger class. So this resolves all the issue that we had prior to this. So enum is another way to create a singleton class. and by just writing 2 lines of code we can create a singleton class which is enum logger instance. So by default enums are singleton only. This is defined by JVM. So all the constructors in an enum are private only. You cannot create any more object, only one object will be created for logger. So yeah, this is it for singleton design pattern. So the whole idea was to create only one object for a class, and you have seen 5-6 ways of doing it. The most efficient way is either Enum or either Pugh Solution. Yeah, I'll see you in the next video with another design pattern. Thank you. So if you have any doubt, do put a comment in the comment section. I'll try to answer it right there.